Miscellaneous exercise 11. We continue with the question number 13 here. There you are given one fixed point and you want the plane. So required plane is perpendicular to the given two planes. So now you know that therefore the normal to the required plane must be cross product of the normals of the given two planes, right? Because whenever you are perpendicular to two vectors, then always you need to take what? Cross product. So I'll write here normal of the required plane is, let me call the vector n, which is equals to cross product of the normals of the given two planes. You know, whenever one vector is perpendicular to two vectors, then you need to take the cross product. Now here, to get the equation of the plane, you need normal. So the required normal must be perpendicular to normal of the given two planes. So we need to take the cross product, and this is very basic fact, remember. Whenever you are finding a vector which is perpendicular to two vectors, then you need to take the cross product. So I've just taken the cross product. So here for cross product, we know here we have I, j, k. What is normal to the first plane? You write the coefficients of x, y and z, which is 1, 2 and 3. Normal to the second plane, that is 3, 3, 1. How I wrote these normals? Coefficients of x, y and z. Now let's simplify this. So you will get here 2 minus 9, which is minus 7i cap, plus this is 1 minus 9, so minus 8 and minus 9, so we'll get the plus 8j cap, and here 3 minus 6, which is minus 3k cap. So now you have normal to the required plane. Here your fixed point, so you can write the equation of the plane. Therefore equation of the plane, that is vector r minus vector a dot normal equals to 0. You know very well. So if I just rewrite vector r dot vector n equals to vector a dot vector n. So vector r as it is here. What is normal to this plane? You know, minus 7i cap plus 8j cap minus 3k cap. Here dot product of this fixed vector and the normal to the plane. So if I write dot product here, minus 1 minus 7, so that is just 7, always plus, you know, 8 into 3, which is 24 here, and finally minus 3 into 2, which is minus 6, and here you can write x, y, z. So if I use that concept, you have minus 7x plus 8y minus 3z equals to, this is how much? 25. So I'll just take minus common, so I'll get the 7x minus 8y plus 3z minus 25. So you have plus 25 equals to 0. So this is the required plane. This plane is perpendicular to given both the planes. What we did in the entire solution, the important point was this: normal of the required plane is nothing but the cross product of the normals to the given two planes. Why we took the cross product? Because whenever you need a vector perpendicular to two vectors, always you need to take the cross product. So that's why. And then just we have used this. I hope this must be clear to you. What is this vector r bar? You know, vector r is nothing but xi cap plus yj cap plus zk cap. You know this much very well. This is arbitrary vector. So x into minus 7, y into 8, 8y, z into minus 3, minus z. And here, this is simply dot product of this vector and this vector. So you are getting this. Fine? Okay. Next, question number 14. The 14th question, what you are asked? You are given 2 points and they are at equidistant from the plane. So here plane is given by this equation. Plane is vector r dot 3i cap plus 4j cap minus 12k cap plus 13 equals to 0. So if I just write in form of Cartesian, then it is 3x plus 4y minus 12z plus 13 equals to 0. That's a plane. What I did, I've just expressed in form of what? Cartesian. This is a plane. Now you are given this, so let's try it. Given that distance of 1 p from the plane, let's call the 1 here, is equals to distance of the plane, this point minus 301 from the plane 1, from the same plane, from the plane 1 here, remember. These two are equal. You are given in the question itself. Now you know the formula for distance of a point from the plane, right? So therefore, how do we write the formula? Modulus of 3 into 1 plus 4 into here 1 minus 12p plus 13 upon under root 3 square plus 4 square plus 12 square. That is equals to modulus of, what is this? Minus 9 plus 0 minus 12 plus 13 upon root of 3 square plus 4 square plus 12 square. So this will get cancelled obviously. Which formula I've used? Just I'll mention to remind you. I've used this formula, if you remember, modulus of ax1 plus by1 plus cz1 plus d upon under root a square plus b square plus c square. This is the distance of the point x1, y1, z1 from the given plane ax plus by plus cz plus d. Right? This is what I've used twice here. So I've used this formula. Now let's simplify this. This will get cancelled. So here the numerator expression is 20 minus 20p equals to, this is 0, or here you will get just how much? Minus 8. So therefore 20 minus 20p, sorry, this is 12p, I'm sorry, this is 12p equals to, this is plus or minus 8. So 20 minus 12p equals to 8, or 20 minus 12p equals to minus 8. So here you will get the 12 equals to 12p. So p is 1 over here. On the other side, if I simplify, here 28 equals to 12p. So therefore p equals to 28 by 12, which is nothing but the 7 by 3. So these are the possible values of p, either 1 or 7 by 3. 15th number, find the equation of the plane through the line of intersection of these two planes. Okay, so we use that theory, if you remember, one plane plus lambda into the other plane equals to 0. So here you are given two planes. Given planes, you can just write equations here. Alright, therefore the required plane is given by one plane here, vector r dot I cap plus j cap plus k cap minus 1 plus here lambda into the other plane The other plane is vector r dot 2i cap plus 3j cap minus k cap plus 4 equals to 0. You know, this is very standard equation of the plane. One plane plus lambda into the other plane equals to 0. We call this as equation number 1. What we do? We are given certain condition in the question. We use that condition, we find the lambda and we place here. Now condition is about parallel to x-axis, so we need normal to this plane. So I'll write in that standard vector form. We need normal to this plane, so I'll write in the standard vector form. So r dot as it is here in both. I'll take I cap common from these two, but lambda will be inside the bracket. So we'll get the 1 plus 2 lambda into I cap plus here 1, this lambda will be inside this 3 lambda into j cap. I hope this is clear to you. Plus, what about this? Here 1, this lambda will be inside this. So 1 minus here lambda into k cap here. This is 1 from here minus lambda from here. Minus here minus 1 and this is plus 4 lambda. Minus 1 plus 4 lambda equals to 0. Okay. So it is in which form? You can see it is r dot n plus d equals to 0. This is a constant. Okay. So now this is a normal to the given plane here. Now we are given that, what is given to us? Given that this plane is parallel to x-axis. It's like this here. So this is x-axis here, and plane is like this. This is the plane, required plane. So this is the direction of the normal n cap. This is the direction of the x-axis, which is I cap. So clearly you can see that this normal and the direction of the x-axis are perpendicular. Therefore, normal to the plane is perpendicular to I cap. Therefore, the dot product equals to 0. Clear? This is the only important concept here. This is the direction of the x-axis, you can see. This is the direction of the normal. So obviously, normal and the direction of the x-axis are perpendicular. So the dot product must be 0. Now we use this concept, so we'll get the lambda and then we place here or over here. That's not important, whichever place you put it. So now what is the normal to the plane? That is this one. 1 plus 2 lambda, comma 1 plus 3 lambda, comma 1 minus lambda. This and this dot I cap. What is that? 1 0 0 equals to 0. Just take the dot product. So 1 into 1 plus 2 lambda plus this into 0 plus 0 equals to 0. And therefore 1 plus 2 lambda equals to 0. And it implies lambda equals to minus 1 by 2. Now we place the value of lambda. Either you can put in equation number 1 or over here, this one. Whichever way you place. I'll call this as 2. So putting in 2. So putting value of lambda in 2. Both are same, remember, whether you put in 1 or 2, that's not important. So r dot, I'm putting lambda equals to here minus 1 by 2. So this will be 0. This becomes 0 I cap. This is minus 3 by 2. So what will get from there? Here minus 3 by 2 plus 1. So minus 1 by 2 into j cap. This minus, and so it will be plus 3 by 2 k cap equals to here, if I take on the other side 1 minus 4 lambda, but if I put value of lambda it will be plus 4 lambda, so it becomes 2. Putting value of lambda, just keeping on the RHS. Okay, so here I can write x, y, z here. vector r means x, y, z dot 0 comma minus 1 by 2 comma 3 by 2 equals to 3. So just take the dot product, 0 into this minus y by 2 plus 3 by 2 into z equals to 3. So I'll get the minus y plus 3z equals to 6. This is the required plane. Obviously plane has to be like this because this plane is parallel to x-axis, so x variable must be absent here. Fine. So the only important concept in the entire solution is this. This is very basic theory. Whenever you ask plane through intersection of the given two planes, then one plane plus lambda into the other plane equals to 0. That concept you have used, remember. Okay, next question. Question number 16 here. So in the 16th question, you are given origin 0, 0, 0 and the point P you are given 1, 2, minus 3. Find the equation of the plane through P and perpendicular to OP. Okay, so let's consider 3 coordinate axes. You will realize what the question says. This origin, this point P, so this is vector OP. The plane passes through the point P. This is the required plane, remember. And OP is perpendicular to plane, that is also given to you. This is a perpendicular. Fine. OP is perpendicular to the plane. Now to get the equation of the plane, we need fixed point. So the point you can take as origin here, P is inside the plane. So your point is this. 1, 2, minus 3. As per our notation, this is point A. And you require normal also. So normal will be obviously, normal is your vector n equals to, what is the normal? A vector which is perpendicular to the plane. Which vector is perpendicular to the plane? Which is vector OP. And which is given by what? This one. OP means this minus this, which is nothing but the 1, 2, 3. This you know, this one is given, this minus this, which is vector OP. Your normal, your fixed point. So you can write the equation of the plane. Equation of the plane, vector r minus vector a dot vector n equals to 0. Okay, so if I just open is vector r dot n equals to vector a dot vector n. Now what is this? R you can keep just as x, y, z. What is normal to the plane? You know, that is 1, 2, 3. Dot product of this one and this one, remember. Vector, that is n, and vector a. So you will get this into this, which is 1, plus this into this, which is 4, this into this, which is minus 9. So we'll get the x plus 2y plus 3z equals to, you will get the here 5 minus 4. So you'll get the x plus 2y plus 3z plus 4 equals to 0. This is the plane on which perpendicular from the origin is drawn here. Okay, so what is important one in this question, that is so here it's my mistake, I'm sorry. Here it should be minus 3. This minus this, so this should be minus 3. Here also minus 3. So this will be minus 3z. This is minus 3z. Minus 3 gives us plus 9. So this become 14. So here, if you take on the left hand side, it will be minus 14. So finally equation is this: x plus 2y minus 3z equals to 14. This is a required plane. This was my little mistake. OP means P minus O. P minus O. So it has to be minus 3. By mistake I wrote 3 here, but now it's minus 3. So we'll get this. The only important thing in this solution, this became the normal, because to get the plane you need normal and the point, and this is the point inside the plane that's given in the question itself. And then this is very standard well-known equation, r minus vector a dot normal equals to 0. So in the question number 17, find the plane through the intersection of these two planes and which is perpendicular to one more plane. So it's just same as one of the earlier question, that is question number 15, right? First we write the given planes. You have two planes here, so write the equations of the given two planes. And therefore the required plane, as we have discussed in the question number 15, whenever you are asked a plane through the intersection of the given two plane, then this is very standard theory. One plane plus lambda into the other plane equals to 0. That is well-known theory as we have used in the question number 15. So here first plane is given by r dot I cap plus 2j cap plus 3k minus 4. This is one plane plus lambda into the other plane. What about the other plane? R dot 2i plus j minus k plus 5 equals to 0. Now what is lambda? Unknown, which we find and will put in the question number 1. How will get the lambda? You are given certain condition in the question, like the question number 15. There it was parallel to x, here it is given that the perpendicular to the given plane. Okay, so like the question number 15 again, we need the normal to this plane. So we'll express in that standard form, r bar dot normal equals to constant. So we'll take I common from this 2. So here you have 1 and here it is 2 lambda. So 1 plus 2 lambda into I cap. Plus, what about this? 2 plus here lambda into j cap. 2 plus lambda into j cap. Plus, what about this? 3 here minus lambda into k cap. I hope this is clear to you, because we did the same thing in question number 15 also. You take I common, this lambda will go inside, so 2 lambda plus 1. 2, this lambda will go inside, so plus lambda j cap. 3, minus sign is there, so minus lambda. Now constant, here you have minus 4 and this is plus 5 lambda equals to 0. That is a constant. So this represents a normal, remember, r dot normal plus constant equals to 0. Now you can call this as equation number 1 here. We find the lambda, either you can put in equation number 1 or in the previous one, both are the same thing. Now this plane, let me write, this plane is perpendicular to, that's given in the question, perpendicular to the planes, to the plane r dot 5 I cap plus 3j minus 6k plus 8 equals to 0. Now two planes are perpendicular. What happens to their normals? Obviously they are also perpendicular. It's like this. Here you have two planes, remember. So one you can imagine this plane, the other one is this plane. These are the two planes you can see. So here this is the normal to this plane and this is the normal to this plane. So this normal and this normal are perpendicular. Think for a while. This is normal to this plane, this is the normal to this plane. So planes are perpendicular, normals are also perpendicular. So this normal and this normals are perpendicular. Therefore, I'll write the normals are perpendicular. Normals are perpendicular. And therefore, dot product of the normals equals to 0. What is the normal to the first one? 1 plus 2 lambda, comma 2 plus lambda, comma 3 minus lambda. That is the normal to the required plane. And normal to the given plane is 5, comma 3, comma minus 6. This dot product must be 0. Normals are perpendicular means what? Dot product of the normals equals to 0. Now we just simplify, so we'll get the lambda. I repeat this step. This is a required plane and this is a given plane. These two planes are perpendicular. That's given in the question itself. Therefore, the normals are perpendicular. So dot product of this normal and this normal must be 0. That's what I've used. Now we are using this. So we'll get the 5 into 1 plus 2 lambda plus 3 into 2 plus lambda minus 6 into 3 minus lambda equals to 0. So here 5 plus 10 lambda, 6 plus 3 lambda, minus 18 plus 6 lambda equals to 0. So let's find lambda from this. Here you will get 10 plus 3, 13 plus 6, which is nothing but the 19 lambda. And here you will get 5 plus 6, 11 minus 18. So we'll get the equals to 7. So lambda equals to, you will get the 7 by 19. Now we put this value of lambda over here. So by 1 we have r dot here 1 plus 14 by 19 I cap plus 2 plus 7 by 19 j cap plus here 3 minus 19 by here 7 by 19 k cap equals to, here I'll take this one on the other side, so 4 minus here the 5, so 35 by 19. Just we have placed the value of lambda in this equation number 1, nothing more than that I did. Okay, so if we just simplify this, let me simplify this. So here after the simplification you have r dot, what is this, 19 plus 14, which is nothing but 33 by 19 I cap plus 38 plus 7, which is 45 by 19 j cap, and 57 minus 7, so it is just 50 by 19 k cap. This much. R dot this equals to, what is the simplification here? The simplification will be 19 into 4. So 76 minus 35, which is 41 by 19. So 19 will get cancelled. So we'll get the vector r dot 39 I cap plus 45 j cap plus 50 k cap equals to 41. If you want, you can write here in form of Cartesian. So you can write x, y, z. So you have 33x plus 45y plus here 50z equals to 41. This required plane that passes through the intersection of the given two planes and perpendicular to one more plane. So in the 18th question you are given the point, 1 point, let me call that point A, which is minus 1, minus 5 and minus 10. This is a given point. You want the distance of this point from the point of intersection of the line and plane. So you are given the line here. Let me write the equation of the line here. R equals to 2i minus j plus 2k plus lambda 3i plus 4j plus 2k. That's a vector form of the line, and the plane is given by here. Plane is given by r dot I cap minus j cap plus k cap equals to 5. Now you want the intersection of the line and plane. Now when line and plane intersect, It's like this. Here, this is a plane and there's a line. We want this intersection point. This is a question. So if line meets the plane, then for some fixed value of lambda, the equation of the line must satisfy the equation of the plane over here. So for some fixed lambda, that will get, you will see, for fixed lambda, r equals to, I'm writing in ijk form. See here, 2 plus 3 lambda I cap, 2 plus 3 lambda I cap, plus minus 1 plus 4 lambda j cap, plus 2 plus 2 lambda k cap must satisfy equation of the plane. And this r gives the point of intersection, right? This is true for every lambda, but when they meet the plane, then you must have some fixed lambda. So for some fixed lambda, we wrote in terms of x, y and z. You can see this is x coordinate, y coordinate and z coordinate. This must satisfy the equation of the plane. So here, instead of r, we are going to place this, and from there you will get the lambda, and that value of lambda gives the required point of intersection. Therefore here I'm putting just value of r. What is that? 2 plus 3 lambda, comma, what we have? Minus 1 plus 4 lambda, comma, 2 plus 2 lambda, dot, ijk, which is 1 minus 1 and 1 equals to 5. Therefore, this into this, which is 2 plus 3 lambda, minus 1 into this, that is plus 1 minus 4 lambda, plus 2 plus 2 lambda equals to 5. So let's simplify this. Here you have just lambda, 3 plus 2, 5 equals to 5. So lambda is 0. So you can call this as 1 here. So from 1 you will get the intersection point, because this point you have placed here inside the plane. So by 1, your point of intersection equals to, I'll call that as b, putting lambda equals to 0. So we'll get just 2 comma minus 1 comma 2. So this is the point of intersection. How we got the point of intersection? Just by finding lambda. We are just putting lambda equals to 0 here. 2 minus 1 and 2. This is the point of intersection. This is a given point, and now we use distance formula. So by distance formula, AB equals to root of minus 1 minus 2 the whole square plus minus 1 plus 1 the whole square plus, here you will get minus 10 minus 2 the whole square. So this is 9 plus 16 plus 144. So we'll get the 169, which is 13. So distance is 13 here. The required distance is 13 here. Question number 19. Find a vector from the line through this. You need a equation of a line. So you need fixed point and its direction. Fixed point you are given. Which is a fixed point here? 1, 2, 3. This is given. We find direction of the line here. To get a line, you need fixed point and the direction of the line. Now, how do we get the direction of the line? Read the question. You will realize the line is parallel to this and this planes. Remember, suppose this is required line. This is our required line. And this line is parallel to two planes. one plane over here and the other plane may be over here like this. The required line is parallel to these two planes, remember. This one more plane over here. So direction of this line, this is the direction of the line vector B. This is a normal to the first plane N1. This is normal to the second plane N2. These two normals need not be parallel. Here in diagram it's look, remember. So this vector is, you can see, perpendicular to both. Because line is parallel to plane means what? Normal to the plane is perpendicular to the direction of the line. You can see in the diagram itself. This is the direction of the line, this is direction of the normal. But this direction of the line is perpendicular to both the normals. So therefore, what is your conclusion? Direction of the line, that is vector B, perpendicular to both means what? Perpendicular to both means cross product of their normals, as we discussed earlier. When you are talking about perpendicular to two vectors, always you need to take the cross product. So direction of the line must be cross product of these two normals. Now we just get the cross product here. So ijk, what is normal to the first plane? Look at the 1, -1, 2. Coefficients of ijk, then 3, 1, 1. Fine, I hope this much you can write directly from the given equations of the planes. Okay, now we just simplify. If I simplify this determinant, -2, -1, so -3 I cap. This is 1 minus 6. So -5, -9 is already there, +5. This is 1 plus 3, which is 4k cap. That is direction of the line. We have direction, we have fixed point. So you can write the equation of the line, beginning of this chapter. So equation of the line in a vector form, that is R plus, here equals to, sorry, we are writing line. So R bar equals to, you know, here a fixed point, vector A plus scalar lambda into direction of the line. So vector R equals to, where is the fixed point? 1, 2, 3. So I cap plus 2j cap plus 3k cap plus scalar lambda, direction of the line. What's the direction of the line? -3i cap plus 5j cap plus 4k cap. Line in the vector form here. Vector R equals to vector A plus lambda, that's the scalar, plus the direction of the line. Vector A plus lambda vector B. Here, you know, this is 1, 2, 3, fixed point. Plus lambda, here -3 plus 5j plus 4k. So in the 20th question, again you are asked vector form the line through this fixed point. So here fixed point is this, which is given by 1, 2, -4. And perpendicular to the two lines. So you need the direction of the line. Now here required line, let me write, required line is perpendicular to given two lines. Now again you have directions of the given two lines. So direction of the required line must be perpendicular to the directions of the given two lines. Therefore, the direction of the given line, direction of the required line, which I called vector B, that is given by cross product of the directions of the given two lines. So direction of the first line cross direction of the second line. It's like the previous question only, remember, because here required line is perpendicular to the given two lines. So direction of the required line is perpendicular to the directions of the given two lines. Now whenever you want a vector which is perpendicular to two vectors, always you need to take the cross product. So cross product of the given two directions gives the direction of the required line. So we find the cross product here, I, j, k. What is the direction of the first line? You can see that it is in the Cartesian form. So the direction of the first line you can write directly. That is 3 minus 16 and 7. 3 minus 16 and 7. Which standard form you are having? X minus x1 by a, y minus y1 by b, and z minus z1 by c. What's the direction of the second line? That is already, I suppose, in the standard form. So what will get? 3, 8 and minus 5. The second line is also in the standard form. Y x minus x1 by a, y minus y1 by b, and z minus z1 by c. Now we just find the cross product here. So if you get the cross product, you will get the vector b. So see the cross product here. What will get here? 80 minus 56. Let me write 80 minus 56 I cap minus, this is minus 15 minus 21 j cap plus 24 plus 48 k cap. So you will get the 24 I cap plus 36 j cap plus 72 k cap. This is the direction of the line, and therefore finally what we'll get? We'll get the equation of the line. So equation of the line in a vector form, that is vector r equals to fixed point plus lambda into direction of the line, where lambda is any scalar, you know. We'll just place the value. What is the fixed point here? Fixed point, you know, this is a fixed point. That is I cap plus 2j cap minus 4k cap plus here scalar lambda, which is 24 I cap plus 36j plus 72k cap. You can keep in this form, but still if you want to take 12 common, so you can write like this finally. Vector r equals to I cap plus 2j cap minus 4k cap. There is a fixed point. You take 12 common. So 12 lambda, you can call the lambda dash, new scholar. So what will get inside the bracket? 2i, 3j plus 6k. This is the required line. What I did, you can keep in this form also, remember. But I have taken 12 common. So here 2, 3 and 6. And this 12 lambda I have called as lambda dash. And therefore this is a vector form of the line which is perpendicular to the given two lines. Question number 21. That's good question. A plane has three intercepts. So equation of the plane is, making three intercepts, you know, x upon a plus y upon b plus z upon c equals to 1. There is a plane which has three intercepts, and its distance from origin means 0, 0, 0 is small p. So p equals to, you are going to use the distance formula, right? So here this is 0, here this is also 0, this is 0. You take on the left hand side, so minus 1 upon coefficients of x, y and z, which is 1 upon a square plus 1 upon b square plus 1 upon c square. What is the coefficient of x? 1 by a. This is 1 by b and this is 1 by c. So we have this here. Which formula I've used? I already told you in the beginning of this session. Again, I'm just writing for you. ax1 plus by1 plus cz1 plus d upon under root a square plus b square plus c square. Right. here x1, y1 and z1 is 0. So these three terms will be 0. Constant d you take on the left hand side. So it is minus 1. Upon coefficients of x, y and z. 1 upon a, 1 upon b, 1 upon c. So we have this. Now if you see the required expression, you need the square. So squaring on both the sides. So 1 upon, it will be free from the square root. 1 by a square plus 1 by b square plus 1 by c square. And now just taking reciprocal. So 1 by p square equals to, just take the reciprocal. So 1 upon a square plus 1 by b square plus 1 by c square. That's what you want. Just you have used this single formula. Distance of a plane from the origin. So x1, y1, z1 becomes 0. Right? This you know. Here the plane is this x upon a plus y upon b plus z upon c equals to 1. That's what you want. Question number 22, that's an MCQ. Distance between these two planes. So which formula? You use, distance. Let me write small p, that is d minus d dash upon under root a square plus b square plus c square. But here you should note that the coefficients of x, y and z should be same. So the first plane you need to multiply with 2. 2 into first equation, plane 1. So what we'll get here? 4x plus 6y plus 8z equals to here 8. And the plane number 2, second plane, these two planes are parallel because normals are same. Now you can see 4x plus 6y plus 8z equals to 12. Coefficients are equal now. Then and then you can use this formula. If you have written directly 4 minus 12, it's wrong. And therefore, distance equals to now 8 minus 12 upon now the equal coefficient. That's a 4 square plus 6 square plus 8 square. Right? I repeat what I did. The important thing is here, coefficient should be equal, remember. If they are not equal and if you use the formula, it's wrong, remember. So here you will get the multiplying the first, or you can divide by second by 2. Choice is yours, whichever you want to do. I just multiplied first by 2. So 4, 6, 8. So we'll get 8 here and 4, 6, 8. Here 12 is already there. So over here you will get the modulus of minus 4, which is just 4 upon here you can take 2 common. So if you take in fact 2 square common, so it will come as 2 here. And what will get inside? This is simple simplification. If you take 2 square common, this is just 4. This is 9 and this is 16. So finally, if you just simplify, this is 2 by root 29. 2 by root 29. Just simplify, I'll get this. And which is nothing but your, which option? D. The only important conclusion in this solution is coefficient should be same. Remember, either you can multiply first by 2 or you can divide second by 2, whichever way you do. But this is the required distance. The last MCQ, you are given 2 planes. Normal to the first plane is this, coefficients of x, y and z 2, minus 1, 4. Normal to the second plane 5, 2.5 means 5 by 2 with minus sign and 10. So you can see clearly here, first normal equals to some constant into the other normal. Right? You multiply this expression with something, you will get this. So normals are multiple, and therefore what about the planes? Planes are parallel. Normals are multiple means normals are parallel, and once normals are parallel, planes are also parallel. So option is B here.